pH after addition of 25 milliliters of base.
pH after addition of 25 mils, yes. Okay, and so now, by the way, just out of curiosity, which equivalence point are we talking about?
Quarter.
The quarter equivalence point. Well, we had to use a quarter molar equivalent of base to this. So I think many of us already know where this is going because there's an easier way to do this. But we're not going to take that shortcut. I want you to do, which equation are we going to evoke for this? The Henderson-Hasselbalch equation. And again, here I'm going to ask you to work it out on scratch paper. The equation should be derived fresh. So what I'm about to do is scratch paper stuff. And then we'll get to the point where we transfer into the actual test. And so my scratch paper is, how do I derive Henderson-Hasselbalch?
Start with the
Mass action.
mass action.
So I take K is equal to
Concentration
what?
of
Hydronium ion
concentration of acid.
of acetate divided by acetic acid. Okay. And what do I do first?
Solve for hydrogen.
Solve for hydronium ion. So therefore I'm just going to go from there to here. I go hydronium ion concentration is equal to K times, and I'll put a little A here because it's an acid constant, ionization constant, and Ka times the acetic acid concentration divided by the acetate ion concentration. Oh, okay, Chris, would you let him in, please? Thank you.
And the water drops out.
And the water is not included. Why?
As effective concentration.
Yeah, because it has unit activity, exactly. The water, so it has effective concentration of 1. Now, what do I do next to get the Henderson-Hasselbalch?
Take the negative log of those.
Okay, so negative log of hydronium is equal to negative log of Ka minus the log of acetic acid concentration divided by the acetate concentration. And so now we're in a form that really gives us great simplification. What is this? pH equals pKa minus the log of acetic acid divided by the acetate. Okay, that is the needed equation. So where this will be your starting point, so everybody has that derivation down, right? That was all scratch paper. That's not going to go in the space provided. So I'm going to erase the derivation. But it's important that you know from whence it came. Basically, this is equivalent to what we did hitting the ice without the ice. And I'm going to just write Henderson-Hasselbalch. pH equals pKa minus the log of acetic acid over acetate. And now, so this goes first. Now I need to show what this is. And the concentration of acetic acid over acetate is equal to. And now we have to take advantage of the fact that for every mole of acid present, for every mole of base present that I add, I'm going to remove a mole of acid, and generate a mole of acetate. So there's a proportionality there. And so let's now take into account there, so there's 2 molar is the concentration of the acid that we started with. And there was, how much acid was there to begin with? There was 2 molar and there was 0.1 liters. And then I added how many liters?
0.25.
0.25 liters. And that is, so this tells me the original number of moles of acid present, since this is equimolar base, minus the amount of base I added. But now I have to take into account the concentration has changed because when I was adding the base, I was increasing the volume. So what's the total volume? 0.1 liter plus 0.025 liters. So that takes care of the concentration of acetic acid in moles per liter. So the units work out. And now that's divided by, now for the acetate, I started out with 2 molar. For every mole of base added, I've generated a mole of acetate. So I start out with 2 molar acid or base, and there was how much? What was the volume of the base added? 0.025 liters, and that's divided by the total volume as well. And so that's 0.1 plus 0.025 liters. So all kinds of stuff looks more formidable than it is. And now everything drops out. That drops out, that drops out, that drops out, that drops out. And we end up going to what's 0.1 minus 0.025? 0.075 divided by 0.025. And that's equal to what?
3.
That's a lot easier. So it went from here to there. I want that detail. Okay. Now, pH is equal to pKa minus the log of 3. And now I can just put in the numbers. pKa was what?
4.76.
And what is the log of 3?
0.477.
477. And that's equal, so I'm going on my scratch paper just to make sure I don't make a mistake. 0.477, that's a 3. This is 15, which is an 8. This is 6 minus 4 is 2. So it's equal to 4.283. Okay? And that, I'll erase my scratch paper over here. This is what I should see.
That's unit 3.
Okay, I want everybody to have that information on there. Don't do the derivation of Henderson-Hasselbalch. Do that on scratch paper. But when you're practicing it, do it every time. Even though you probably know Henderson-Hasselbalch by now without deriving it. It's just good practice to go from a law or some primitive equation to the appropriate expressions that you want. Okay? So do that. So does that answer that question? Okay.